Hello, good evening, everyone. I hope I am audible. I welcome you all to GRE Preparation Made Easy Quantitative Reasoning class by Mrs. Annapurna Murugan. Here are a few instructions for the participants. Make sure you have a stable internet connection and noise-free environment. We recommend you to use your earphones for best experience. Also, please respect instructor and your classmates. Don't write anything inappropriate on the chat box. Also, how to answer the polls, you have to click on the More button where you can see activities and you will be headed towards polls section. Also, we have three packages, that is bronze, silver, and gold. I have already provided a coupon code to shift from upgrade from basic to bronze package. Also, if you upgrade to silver and gold packages, you'll get extra benefits like evaluated mock test, expert university recommendations, dedicated counsel for the entire application process, and so on. We also provide free profile evaluation with our experts. You can book a slot through our website. It includes comprehensive evaluation, university shortlisting, course recommendation reports, and doubt clearance. Also, IELTS classes are conducted Monday to Friday, 7:30 to 8:30 p.m. and Duolingo classes Monday to Friday, 6:30 to 7:30 p.m. You can register for free. Also, we have this webinar on 16 December from 7 p.m. to 8 p.m. It is regarding how to score a good percentile in IELTS. It includes the exam pattern, preparation, ways to prepare, and time management skills. We are also providing one-on-one IELTS classes. It starts from rupees 5,999. It includes 20 hours live classes, class recordings, daily class worksheets, 10 plus sectional tests, and 5 full-length mocks. Here are a few achievements. So this is the Ubergrad website. You can select the country, course, and specialization. When you go and explore, we have countries, universities, courses, and exams. You can get all the information from here. When you go on solution, we have admission. That is when you go here, just a second. Yeah, you can book a slot and it's free of cost. So yeah. This also includes test preparation stores, additional services are provided. Also, weekly blogs are uploaded. You may go through them. Also, when you click on upgrade, you can find our packages, basic, bronze, silver, and gold, and you can see what each package provides. Also, when you click on my test preparation, you get the handouts and the recordings. So in case you've missed any sessions, you can go through the handouts and recordings for your benefit. For any other query, you may ask at the end of the session. Thank you.
Hi guys, good evening. I hope everyone is doing good. Yeah, today we'll continue with our session. So that's DI. Okay, today we'll be dealing with different graphs, how to evaluate them, and how these questions are given, and what are the key things that we need to keep eye on. Because basically, solving these DI questions very simple. They don't actually involve any kind of complex this one calculations or something like that. Here will be only having what just it will be purely simple calculations. Only the thing that what you need to keep in mind is you need to see like what question and how the question is asked. Okay, so this one is that keep concentration on what kind of question it is and what they are asking. So let me share the screen here. Yes, here we go. Yes, I guess everyone can see the screen. Okay. So this is a table. Like they give the statistics. On the basis of this, you people need to find so the answers, or you need to answer the following questions here. Okay. Now, see, look at the thing. They have given the data like this. What is this? Ninth grade students at Millbrook High School. Okay. So we have two sets. I mean, even two categories, boys and girls. See, the tip here is that whenever they give the graph, I would strongly recommend, it's not only graph, any statistical information, kindly look through the information properly. Okay, it is crucial. You need to go through the information properly, because you cannot just randomly get on to the question or options here. So, and also simple calculations to be done by you guys. So what they are given, so they are talking about ninth grade students of Millbrook High School. We have boys and girls. So, and we have two categories here. What are two categories? People who have enrolled and people who have not enrolled for the classes here. Okay, so these two things we have here. What is that? People who have enrolled and people who have not enrolled, and that too based on gender. Okay, so now here this is the thing. So that means totally how many people? Let us make a simple calculation. We have 25 people totally enrolled, and people who have not enrolled is what? 35 people. So how many people have not been enrolled here? So 35 people not been enrolled. So total number, this implies total number of students will be how much? So it is 40, 60 people we have. Now, let us try to take up the question. This is the basic idea. This is the basic thing you people would have understood. And how many boys will be having? So 12 plus this one, it is 31 boys and 29 girls total. Okay, in that school. Approximately what percent of the ninth grade girls at Millbrook High School are enrolled in this one? So now they're asking approximately what percent of the ninth grade girls have been enrolled to Spanish class. So what you will be doing? So ninth grade girls they are talking about. Should we take this one? You all know that. So change in number, change in value divided by total value into 100. This is the simple formula that you need to do. So here, how many have enrolled girls? 13. So out of how many? 16. 16 girls have not enrolled and 13 girls have enrolled. So that means totally girls, how many were there? 29 girls we had. In that, 13 girls have been enrolled. And what is this one we have? So it is this one. When you equate this thing, so how much percentage you will be getting? So when you equate this, you will be seeing that you will be getting 44.8%, so which is nearly equal to 45%. Kindly do this calculation. We see what? It's a simple calculation. I'm just telling. So this DI things are very simple. Only the thing is you people need to understand what is the question given here. Next thing. What fraction of students, see, they're asking now students, what fraction of students in ninth grade at Millbrook School are boys who are enrolled in this one? They're asking for the fraction. But the fraction of students to boys enrolled. How many members boys enrolled? Only 12 members. And what is the total number of students we have? So 60. Therefore, the fraction is so 12 by 16. They're not asking what is the fraction of the boys so who enrolled for this one. No, they're asking the total students. That means what? It includes girls also. So total number of students we had 60. In that 12 and enrolled. Therefore, what? 12 by 60. When you see 12 ones are 12 fives. So 1/5 of the thing. So we can say 1 by 5 is the, and always the fraction should be in simplest form. Okay, don't try to see that, oh, 12 by 60, let me check it up where it is. No, it is always should be in the simple form. You people know that. So then The next question is what? What ratio of ninth grade students, ninth grade girls not enrolled in Spanish? They're asking what ratio of ninth grade girls not enrolled in Spanish to all ninth grade students at the Millbrook Middle School. So we know that. So how many students we have? 60 students. But how many have not enrolled? Especially girls, they're asking. So how many have not enrolled? It is 60. So therefore, what you can do? You can write, sorry, it's not 16. What is it? Not enrolled is 16. Yes. So what you will be doing? Wait. What is the ratio of ninth grade girls not enrolled in Spanish to all this one, ninth grade students at the this one? So how many girls have not enrolled? 16 and is to 60. Do we have any this one that can go to 8s, to 30s, to 4s, to 15s? So therefore what? 4 is to 15. Getting it? What is that we have? We have 4 is to 15. See, simple calculations. And then what we have here? If X% more ninth grade students at Millbrook High School are not enrolled in Spanish than are enrolled in Spanish. What is this X? They're asking, what is this X? So when if X% more students, okay, X% more students in ninth. So basically what did we do? Let us take how many enrolled. We saw that the total enrolled was 25 and 35 did not enroll. Okay. So they are asking us what? How many students basically did not, total students did not enroll, isn't it? So that is the thing that we have here. So let us take. Now tell me guys, how many students so have not enrolled here? So if we see here, how many? 35 out of, what was the students? 60 into 100. Tell me what is the percentage that we have? 35 students have not enrolled, so over 60 students. 2 3s, 2 5s. So take 3 1s, 3, 3 6, 8. Okay, so check it out. How much? So then you people can group it. So that is the percentage of students so who have not been enrolled to Spanish in our this one. Okay, so that's the thing. So it comes around 40%. Okay, nearby it comes around, so 40%. So that is the thing we basically can take here. Or one more thing that you can take is better. What is the difference? So 35 students not enrolled, 25 students enrolled. So you take in this way rather than going in this way. I would recommend, yeah. One easy way is, see, 25 students had enrolled, 35 students had not enrolled. So 35 minus 25, what is the difference? 10 students. So 10 students when, that is the difference between enrolled and non-enrolled. So if 25 to the original number 25 into 100, that means when compared to this, we have 10 students difference. So it becomes, suppose 40% of them have not enrolled. That is the difference between, so basically the students who have enrolled and enrolled. Okay, that is the thing you can take up. Now, if two of the ninth grade boys at Millbrook High School who are not enrolled in Spanish, so decided to enroll. So what we had first, let us put the table here. Okay, so let us try to just, because we have certain changes. So boys, girls, okay. And then we are, what is that we have? They're asking enrolled and non-enrolled and not enrolled. Okay. So previously what we had, we'll see 12 enrolled, 13, 19 and 16. So what? Initially 12, 13. So then 19 and 16, isn't it? We had. But now what is that happening? If two of the ninth grade boys at Millbrook High School were not enrolled in Spanish, decided to enroll in Spanish. That means, so out of 19 year, people went off to. So this number becomes what? 17 year. Okay. And then 8 new girls and 7 new boys were also enrolled in the ninth grade at Millbrook and also in Spanish. That means what? So the total number of students also enrolled increased and also they were added on to the Spanish. That means what? 7 boys and 8 new girls were added on. We already had how much students? 60 students. In that 60 students, like 715. So totally now total students 75 and total people basically will be taking the Spanish would be what? 13 plus 8, 21 and here also it is 21. So that is 42 students out of 75 students. 42 students are enrolled for Spanish here. So therefore into 100. So 25 3s are 25 4s are. So 3 1s are 3 4s are. Around 56%. What is the this one? So we have 56% students. So who right now has enrolled for the Spanish thing. So these new alterations, you should know these new alterations. So they did, what is that? Enrolled to the school also as well as Spanish. And here also you should remember, if 2 have been added on for Spanish, that means non-Spanish will become reduced here. So these 2 modifications you people keep in mind how to do. Now, this is the stacked line graphs. So what we call them as? We call them as stacked line graphs. Why stacked line graphs we are talking about, miss? So in one single graph, they are trying to give 2 to 3 things, two or more descriptions or 2 or more type of data. If it is given, we call them as stacked line graphs. Okay. So now here, what are the data that they have given? So some numbering versus years. Okay, and always remember when in our what is that XY graphs, you always see that. So this years, time, everything. So it always lies on x-axis here. Okay, so therefore here you could see that. So for electric energy cut, we have, so like this is the electric energy cut. Okay, don't get confused because they have given the indication here what is energy cut we have. Okay, so that is the thing we have, whereas this is what average temperature. This is given average temperature in terms of Fahrenheit. Don't get confused here between the graphs here. So let us try to see. Now they are asking electric energy cost increased most between which two consecutive months? They're asking between which two consecutive months the electric cost basically increased most. Most in the sense what? Maximum. And in these graphs, how do you find maximum or minimum? The steeper the graph is, if it goes like this, the steeper it is, the maximum it is. Okay, so let us see here which one electric cost they're asking. Don't look for this diamond base. This is the circle based. So where we have the steepness, I could see the steepness is completely here, because they're asking increased. Okay, so increased in the sense you need to see only raising wala. So here if you see the steepness is more, but they're asking between which 2 months. So therefore you try to observe this and this. If you see this between this and this between this, if you see, it is crossing what? 100 to 120, 120 to 140, that is more than 40, more than 40 plus here. Why? 100 to 20 is 20, 20 to 40 is, so again like 40. But in between this, what is happening from here to here? It is approximately 30, I guess. Even if you take 70, so 70, 10, 10, one, this one. So it is around 30 plus we have. So whereas from year to year, it is least. So between which months it is more? You can see between July and August. The rise is when? That's what, as I said, the steeper it is. As the slope is more, the increase is more, or the decrease is more. Remember that. If the slope is more, so then we take, whether it could be upward slope here, downward slope. So you should see the slope to identify, so whether it is increasing or not. Okay. If the slope is least, then it will be the least one. Okay, so almost, so here what we did, so in which, between which month? July and August. Between July and August, it was maximum. Then before, after the second highest, it was between June and July. Okay, it was second highest. And then between May and June, it was the third highest, we can say. Now, next one. Same question, see. Electric energy cost changed least. Okay, between which two consecutive months? They're asking between which two consecutive months did electric energy got changed. Okay, so I mean the least it was. So least, you see, least in the sense electric energy less. So the more, the less year one we have. Okay, and if you see here also almost stable. Yeah, students get confused. Oh, this is stable now. I cannot say there is a change. Yeah, this implies what? Zero change. Zero change in the sense what? Least change. Isn't it? So it is not changed here. It is zero change. It is least change. So not this. It's not like always we need to have like this or like that. That even if it is stable, so that implies what? There is no change. What does that imply? That implies that we don't have change. So therefore, April to May is the thing where the change is very less. What it is? The change is less. Where, which month? Which is the combination of month? It is April to May. So can you guess? So between these 2 months, so our least change, energy cost was least here. Next, approximately, what was the average electric charge cost per month in the first half of the years? So we discussed about average. So average means what? You need to sum. But for what they are asking for half of the year, first half of the year. So take up the values. Energy cost. What is that? Year approximately for January it is 70. You need to take like this. Just give me 1 second. Ha. So January I can take approximately 70. I'll take approximately 60. Here also 60. Then this is approximately 50. Next one is also 50. Then June it is coming up to year. That is approximately 70. Okay. So when you add up and see how much divided by 6 for 6 months, right? So you will be getting approximately what? So 360 by 6, which is $60. Getting it? How to find? You take the values, corresponding values for, so 6 months divided by 6, that gives you the per month average we are going to get. In what month was the electric energy cost per Fahrenheit of the average temperature least? They're asking what? This is slightly a tricky question. They're asking in which month electric energy cost per Fahrenheit. Electric energy per Fahrenheit was least. Okay. That means you need to divide electric energy, that corresponding month's electric energy divided by temperature consumption. That gives us the, this one, what is that? Whatever the combination they have asked. But when you can say this is least, so when numerator is less, then you can see that, so that fraction will also be less, isn't it? So let us see where the energy is less. Where we have energy less, in which this one, what is that energy is less? If you see here the temperature and energy almost the thing, and here also it is less. So in this case, what is happening? The denominator is greater, but in this case, the denominator is lesser. So therefore, what we can say, so it is in this month, okay, in this month that we have the temperature less. That is which month? May. Check it out. April here, May. Wait. No, in this almost equal it is. Let me erase this so that you people will understand. Just give me 1 second. I'll erase this so that it will become clear. Shit. Just, I want. Just 2 seconds, guys. This is almost equal, guys. Here we have. If you see, so this is almost equal. So equal means it is coming up to 1. So it won't be less. But if you see here and this part, okay, you will be seeing the numerator is lesser than the denominator. So I can also take here also the numerator is lesser than the denominator. But the difference between them, see, numerator is lesser than denominator we have. Okay, so if the difference is maximum, the value will be less. Okay, here in this case in November, what we have, the difference is very less. That means they're almost near to 1. Okay, and this one was almost 1 only, so we did not take this also and this also, where the difference between two things is low. So in this case, and even the electric charge is minimum at this cost. So therefore, this by this. So therefore, it is in the month of May, we basically have this particular thing. So here, what is that? In the month of May. Why? Because April, it is almost 1. November, if you see, it is almost near to 1. So, but here the difference between the numerator and denominator is very high. So, that is the reason. So, what happens? This will be very less than 1 year. Okay, so therefore, that is the least. This one, electric energy cost per Fahrenheit, we are going to have. Now, this is one more graph, that is bar graphs. Okay, what is this? This is our bar graph. Let us try to see this and work on this. Okay, what they have given here, you can see they have given, this is also stake graph, this one bar graph, I can say. Why? Two graphs discussed here. What is that? So you can see 1950 we have 3,000 students, comparison on that. So GPA. 2000 also we have the students, number of students and the grade points here we have. Now, what was the mode for the GPA among the 3,000 students in 2000? What is this mode? What is mode? Mode in the sense what? Maximum number of students. They are asking. So mode for GPA in the sense which GPA was maximum. Okay. So among the 3,000 students in 2000. So try to see here. So when you see, what is that? Where in which we have this mode, where which is highest 2000, right? The number of students highest, this one. So it comes where? It comes to 3.3. So therefore, it is 3.3. Okay, what is it? It is 3.3. Next, what was the median grade point average among the 3,000 students in? See, 3,000 students, this is an even number. So what you will be getting? So you need to get, so this one between 1,500 to 1,501. Median means what? The midmost thing. Okay. So what is median? Midmost. So median should lie between this thing. Okay. But you're asking what is that grade point where we have this particular thing in 1950. So let us go here. Okay. So let us try to see how many students like we have median. See, in 1950, out of 3,000 students, we have 4 GPA. How many have got? Add up. 4. We have approximately 150. Then 3.7, how many we have? Around 220. I can take. Okay, that means totally your students we have what? 375. Then 3.3, how many we have? So we have, this is around 300. So total 300 plus 375, it is 675. Because total these many students have got below and above 3.3. And then 3.0, how many we have? Say 450. 3.0, we have 450. So this becomes what? 1,125 we have approximately. 400,000 and this one, what is that? And then 2.7, how much we have? 2.7, we have approximately 475, you think? 475. So that means it is around 1500. So therefore, where it is? It is, so in our, this one, what is that? Which grade? 2.7 CGPA. Okay. So 2.7, we have, what is that? We see that students' median class is what? This one. So therefore, what was the median grade? It is 2.7. Okay. Got this? So what it is? So it should be 2.7. Next. Approximately what percent of students in 2000 earned at least a 3.0 grade? At least a 3.0 grade, miss. 3.0 plus also is included here. Okay, 3.0 plus is also included. You can see how many have taken. Already we had at least 3.0 in the sense these many students. Till 3.0 is how much? So you can say totally 1125 out of 3000 students, we have these many students. Okay, so 1125 divided by 30. So it is how much? Oh, sorry, it is for 1915. Sorry, we need for 2000. They're asking for 2000. So you can see here, this is what? 350. Sorry, guys. 350. Then this is for 510. You take. And this is for 610. Then this is 500. So it's approximately 70. So 75, 10, 5, 10, and 19. I'll take approximately as 2000. So 2000 divided by 3000 into 100. So if you see here, this is for guys 1950. But if you see this one, so for 2000, we have this here. Okay. So, sorry, you can take here. So it will be around 67%. How much we have? Around 67% student of 2000 has taken at least 3. Remember, at least 3 means what? Not only 3, but above 3 is also considered. What we can say, above 3 also will be considering here. Okay, not just 3, but above 3 also will be considering. So around 67% we can take. Okay, next. This was for 2000. Okay, so now see, approximately what percent of students in 1950 earned a grade point average less than 3? So we saw here how many students had scored around 1125 students approximately scored at least 3 and this one, but they are asking less than that. So you people count it. So it is like, what is that? 450. So here 500, 950. So 950 again. So you can just subtract. So you will be seeing that. So you will be having around 2000. So 875. So what is the number of students? So 2875 divided by 3000. No, we had, sorry, 1800 and total is this one. Nah? So 1875 divided by 3000 into 100. So calculate here and get me. So you will be getting the options here. It will be a what? It will be around 62.25%. So they have scored less than this one. Okay, what percent of students in this one? So it is around, so this. Now, this is the pie chart you need to take. So pie chart is again what? It is like, it is considered out of 100%. Okay. What is this? It is completely 100%. And also they have described this 11 point, under 11.1%, we have 2.6%, 6%, and 1.8% this and this. So let us see. They are comparing the people. This is the total number of households. Okay, owners occupied housing, these total household by house size. In this, if they ask the numbers, you need to take the percentage. How many households were having? So 4%, then 14.5% into this much gives us the numbers. Okay. So, but now let us see the questions here. So they have said 1%, how much? So 2%, 3%, 4%, then we have 5%, 6%, and 7%. Now, what percent of owners occupied housing units are households with fewer than 4 people? So, fewer than 4 people in the sense what? We need to take up. So, less than 4. So, less than 4 in the sense 1%, 2%, 3%, and this one. So we can't take this 14.5. Why? 4%. Fewer than. That means still 3% we can take. So what is that? 1%, it is, see, 1% is 21.6% plus 2%, 36.3% plus, so 3%, 16.3%. When you add up these things, you will be getting around 74.4%. Okay? So what? So approximately we have 74.4%. Next one. Among the owner occupied housing units represented in the chart above, approximately how many households are 5% households? So they are asking among these people. So how many are 5% holders? Let us see. I said you right. They may ask this one. What percentage of the people are this one 5 old? 6.7. So 6.7 by 100 into, it is approximately 76 million, I can say. 76 million I have. Okay. So now when you cancel out these things, so you will come to know, when you multiply this, you will come to know how many this one. So it is approximately, when you multiply, it is coming 5 million. So 5 million. So is the number of households with, what is that? 5 persons. Okay. So you can say it is 5 million here. Got it? Now, yes, this is one more nice question. Which of the following is a correct ranking of 1% household, 3% household, and so 5% households based on total number of people living in such households? Okay. So let us get back here. Total number of people. So in 1%, what is that household? We have 21.16. So in 1%, what? 21.16 households. So 3% we have, so 16.5%. So, and then, so what do we have? In 5%, what is that we have? So we have around 6.7. In terms of percentage, if you see, so you will be seeing that. So you have what? So 6.7 is less. Then come this one, 5, 3, and 1. But they are not asking for number of households. They are asking for number of people. Check it out. So what is that they're asking? Total number of people leaving. That means in one five persons household, in one household, 5 people will be living. So how many like that 5 households are there? We have 5 million. If you take here, so how many households we have? 5 million households. So if 5 million household we have, so that means 5 into 5. So how many households will be having? 25 million people we have in 5 this one. How much? 25 million. Now when you compare this, so 16.5%, obviously it is greater than what? So it will be double than this one. So 6, it will be almost 3 times. That means, so 15 it will be, so 15 into 3. So that is almost 45. And this will be the less, you can say. Okay. So therefore it goes how? What is the thing we have? You can say 1 person less number, because 21 million means, say, approximately 6.7 is, you take approximately 7 is 5 million. So 5 means here you will be saying 15 million people we have. But here what is happening? It is 3 times this. That means it is approximately 45 million. But if you see here, in this 5 men people, we have 25 million. So in terms of least increasing order, so 1 household, then 5 household, then 3 household. So we'll be taking like that only. So what? 1 household, 5 household, and 3 household. So B should be the correct number. So what is that? So B has to be the correct one, so that you can take it up. Yeah, here usually students go by percentage, but they are asking total number of people. So 5% household, in the sense, it says that in one household of this will be having 5 people. Okay. So if we had 5 million households like this, that means total number of people living is how much? 25 million. But if we had 16.7 million, 16.7%, so 3 persons, that means approximately this was 6.7. Okay. 6.7, if I take approximately 3 times, okay, so that is 6.7, 3 times it will be going nearly 3 points. If I take also, so you will be seeing that for one time it is 5 million. Okay. So 3 times means here only approximately 15 million. 15 million households are like this. So that means approximately 15 into 3. So if not 15, also 12, if you take 12. So 12 into 3 is how much? 36 million. It will be on a greater side. Whereas this one, what is that? Even though 21.6 or 7 we have for our one household. So that means 3 times only you take. So 3 times means 15. So because in each household only 1 person will be there, we can have only 15 million people here. So taking this calculation, we pick this as our choice. Okay. I hope everyone understood here. Which range of household size inclusive accounts for more than 50% of all owners occupied use housing units? What is that they're asking? So which range of household sizes? Okay. So inclusive accounts for more than 50% of so household occupied. Now check out. Together, okay, they need to be more than this one. I guess if you take, see, 36 to 21% also, it is more than 50. So 16 and 36 also more than 50. If you take 2% and 4% also, it is So more than 50. These combinations we have. Let us see. More than 50. So more than 50. So check, we have 2 and 3 also. So, and in fact, 3 and 4 also we had. So, and also we had 1 and this one also. In that, you take the maximum. Sum it up and take maximum here. Which is this 2, 1 and 2. How much you have? 36.3, 21.6. You will be having 57, 1 to 2. If you take 2 to 3, 36, it will be lesser. And this both will be lesser. So 1 to 2 will be greater here. If you compare, you will see that 1 to 2 persons will occupy the greater one. So we don't have that. So if that is not there, then let us pick the other one. We had 2 to 3. 2 to 3 will be more when compared to 2 to 4 here. So therefore, let us see that 2 to 3 we have. Yes, this will be the greater one. Accounts for more than 50% of all the owners occupied. So this is how you people need to do the questions here. It's all like that only. Okay. I hope you people understood and the simple calculations you got to know. Okay. Right. Any doubts on this? No? Okay then, guys. See you tomorrow.
Thank you, ma'am. Also, if you guys have any doubt related to the Ubergrad website, you may ask now. Otherwise, I'll be ending the session. Thank you.